So the proportion of students who live off campus is claimed to be less than 68%. So the population proportion of interest is the proportion of students who live off campus. We'll start with the definition. So what does the claim suggest? The claim suggests P, that is my notation for proportion, is less than 0.68. Yes? Now, should I write that over here or there? In other words, the norm or the alternative? Less than P is less than 0.68. Huh? The statement without the equal sign must be in the alternative, and in majority of cases, the right thing to do is to test for the alternative. Some books will test for the non-undergraduate books, but we test for the alternative. The null is 0.68. We got a sample. The sample of 6 students showed that 65% of the students lived off campus. Well, P hat is given in this problem, which is 0.65, the sample proportion. And the number of students that we used in the sample is N. N is 6. How did we find the test statistic B last time? Number of successes. How do we find the number of successes if the probability of success, which is the probability or proportion that a student would live off campus, is 0.65 and N is 6. So 65% of the students live off campus, and that's based on a sample of 6 students. And if I asked you how many out of those 6 students lived off campus, what would your answer be? Multiply 0.65 by 6, 65% of 6. And 3.9. So even though some say that it's better to round up all the time, let's just round to the nearest integer. So in this case, B is 4. Good. Now we want to find the critical value on which side? Is the process similar to what we did last time, or is it slightly different? Where is it different? It's less than 0.68 instead of greater than 0.68. So if your null is 0.68, a right tail test would test for data being pushed away to the right. In this case, the claim is less than 0.68. So the farther you go away from 0.68, the more evidence you find toward the alternative. So we have to move toward left, your left. It's all a matter of perspective. So that would be the claim. And our protection region will be on the left-hand side. The book calls the left-hand side projection region as C sub-alpha, or not the rejection region, left-hand side critical value. And how did we find the critical value last time? What is the first thing that we did in an exact test? We created something. What did we create?
Distribution.
The distribution. So in this case, we have to create that discrete distribution, which is binomial, n is 6, and p naught is 0.68. So that is our null distribution. So what are the possible values for x? The number of successes. The minimum would be 0, and the maximum yes. We can't use the same probabilities that we used last time because n and p are different. So 6 and 0.68. But we don't have to struggle a lot. We can easily find this probability. So we can use the start button. Let me clear the list. Second 1, comma, second 2. Because we had values in list 2 last time. Now press start. Go to 1. In list 1, I'm going to enter the possible values of lowercase b. And it's actually right because I called the value variable as uppercase b. So probability of uppercase b equals lowercase b. So possible values of lowercase b, 0, 1, 2, 3, 4, 5, and 6. We want to find each of those values. What do we use? Do we use binom PDF or binom CDF?
PDF.
PDF. So go over to L2 and second bars. It's option A, like that. We want to enter NPX, N in this case is 6, P is 0.68, the value of X is in L1. Enter. Does it match up?
I didn't put 0.68, I put 0.65.
Ah, it should be 0.68, it should be the null distribution. This is the sample statistic. So null distribution, so N and P naught. So the values are 0.00107, 0.01369, 0.0727. Yes. I actually don't have to write everything out. Do you agree? I've already hit the value of alpha. The value of alpha is 0.01. I hit it already, so ... you can fill it in. It's not waste time. So the value of alpha is 0.01, not 0.05. It's just habit. Where do we hit that value? Well, 0, okay. So we have to find C alpha such that probability of B less than or equal to C sub alpha is alpha, 0.01. Yes? Less than or equal to what? The number that you choose must be 0.01. Well, could it be 0? Yes, 0.00107. It's less than 0.01, perfectly fine. We have to add, because we are looking at the cumulative probability. The moment I add this to that, my probability is 0.014. Yes? 0.014 exceeds 0.01. correct? So C sub alpha must be 0. Exactly. But this is a binomial distribution. We cannot have a 0. Do you agree? Excuse me, we cannot have a value below 0. Do you agree? You cannot have negative number of successes. So the only way we are going to reject the null is if the test statistic hit that 0. Correct? Did it hit that 0? No. 0 is over here. The regular test statistic is over there. So we do not reject the null. It has to fall in the rejection region. By all means, there is no rejection region in this case because nothing falls below 0 in a binomial. So the test statistic must exactly be 0 for us to reject the null. Obviously, it is not. So even though in the problem, when we started, the sample proportion was 0.65, which is certainly less than 68%. Do you agree? So even though 65% is less than 68%, we cannot conclude that we have found evidence toward the claim because it might be less mathematically, but it's not statistically significant for us to find evidence toward the claim. Does that make sense? So
Where did the 0 come from again? Below the 0.01.
give me 1 second. So
For the original.
So just like last time we kept adding probabilities from the right-hand side because we wanted to find probability greater than or equal to. Here, it is a left tail test, so we're finding the probability less than or equal to. So less than or equal to 0, 0.00107, clearly less than 0.01, perfect. The next value is 1, going to add these two. The moment I do that, it exceeds 0.01. So I have to stop right there. And what is the only possible value? 0, because we cannot have negative number of successes. Does that make sense?
Yes.
So in this problem, the rejection region is that 1 point. Will your conclusion change if you change alpha from 0.01 to 0.05? But in the sense from reject to or do not reject to reject. Or will it stay as do not reject? It is going to stay because even if you said alpha is 0.05, when you add these two, it is going to be less than 0.05. When you add those three, it is going to exceed. So C sub 0.05 must be 1. So our critical value would be the region less than or equal to 1. Clearly, the test statistic is 4. So you still would not reject the null. Are we clear? And what is the exact critical or exact level of significance for the critical value we found? It is actually the sum of those two. So the actual alpha for the problem is 0.00107 plus 0.01369. What do we get when we add those?
Then it should stay at 0.
Thanks. Someone's paying attention. So the critical alpha, or the alpha corresponding to the critical value, is 0.0107. So which would be more precise to right here, you write it as C sub 0.0017. Good. So do we follow